All right, so I want to talk about Unity standards and specifically about when not to apply them. If you look around the internet, you can find all sorts of great coding standards, and they're valuable. I do say that you should be following some set of standards. You should typically have reasons why, you should understand why you're implementing them, but you should have them. So let's talk about exactly how and what you should be doing. So a hard and fast rule on this, just to get to the point right away, is does your code affect game state? If it doesn't, do what you want with it. The bugs that are really challenging, the things that are hard to maintain, are the state in the data, the changes in the data that can happen at multiple different places in your application. So when you're trying to track down why a value is set to the way it is, or what's happening along its path to get to you, it can be really tough to find that out. And that's because there are lots of things affecting it. Now, if you do not have lots of things affecting it, if you are not looking at this game state, the only bugs that should happen there are the ones that are going to be incredibly obviously isolated to that one piece. It should be easy to identify what it's for. So let's give an example. Let's talk about buttons. So a UI button inside of Unity is very common. You might have it in your menus, might have it on your user interface. You might have, it might be touch buttons, it might be mouse click buttons, whatever the type of game you're doing. So let's say that we wanted to create a visual effect. So every time you click on it, it bounces. Or every time you click on it, it shrinks down and pops back. Or every time you click on it, it vibrates or shakes and then kind of comes back to a stable position. But whatever the case is, it's something changing visually about it. And we write a very simple script that just comes in and on awake, it looks into the components for the same game object and says, is there a button? Great. If there is, I'm going to tie it up with my with a method that will respond to the user click. So when somebody clicks that button, it'll also trigger this piece of code. And then it does its thing. It doesn't look at game state. It doesn't care about the game state. It only cares about that button, that one thing it is specifically interacting with, and nothing else. So that's a point where it's like, why do we need strong standards there? A lot of times we can finish scripts like that in 5 minutes, but then still have to spend another hour where we don't want to show it to anyone yet. Even though it works, we don't want anyone looking at the code because of how ugly it is. We don't want that kind of thing in our code base. No, but it's isolated. This is isolated. It doesn't affect other things. You're not creating the complications that most people are worrying about with their code bases. So let's talk about a larger one and where we should be splitting stuff up. So let's talk about InGame Economy. Let's talk about the money that your character has. Well, usually it's just an integer that has whatever number of coins that you have that you can spend. So that could be done in a variety of different ways. You could have that stored inside of a player management script. You could have that stored inside of an economy script. You could have that stored inside of a score manager specifically, where here's your score, here's your money, here's a link to the display. It's going to update when it changes. It does everything it needs to. It's isolated, but it's also holding on to game state that a lot of things are affecting. You could also do that with an observable, where an observable, if you're not familiar, observable is just basically a variable that is named. So in this case, it would be like player income or player earnings. Player cash, points, credit, whatever. And it has an event on it that whenever that changes, it will notify anything listening to it. So I'm calling out to whatever all these methods are. And then those methods, they don't need to check every single update to see if it changed, like your UI element to show you how much coins you have. That doesn't need to look every single update and keep updating. It only cares about when the value changes. And so that's when it's going to set the value or display the value. So there's lots of different ways, and I'm going to I'll just continue my explanation as if this were observables. The observable portion of it matters. That you need to test because lots of things are interacting with it. You are identifying a specific way of how your data is changing over time. Your UI element, where it's listening to it, is not making changes to it. It's only listening and displaying. If something goes wrong there, it's pretty obvious where to look. Okay. So where do we start changing our code? Because honestly, for me, this is an architectural change in our code, and it leads to a huge amount of relief inside of projects. Where do we split this code out? Like where is that boundary when we're writing stuff, and how can we apply it? So I had the hard and fast rule. Does it change game state? If it doesn't, do what you will. That is a great place to split this. One of the examples I gave of this was we have a player component, or we have a scorekeeper or a money component that it manages how much money you have in the game, and it also updates the score. And honestly, this component is so small that I would say that it's isolated. It could be considered safe as is. But you have a standard of how that's being applied. And then you're also writing out how it's being used, different things, how they can read to find out about it, to get that, how they can change the amount that's in there. That is important to have in it. When that's also doing something mundane, something that doesn't affect the game state, like updating the UI, that doesn't really need to be handled by it. That's one of the reasons I like observables. We start to split that logic out. Again, this is one of those gray areas where honestly the component size is so tiny, or can be so tiny, that it doesn't need more consideration. And that's a complication that I think a lot of architectures run into. It's like, well, we're usually splitting our code up like this. We have this hard and fast rule of where we do things, but then we're taking something that might fit into like 10 lines of code and splitting it into 3 classes. And it's sort of like, do we really need that? And so this principle is more based along that idea. How can we simplify things, keep it simple all over the place? Okay, so we can start splitting stuff out. As we start seeing these elements, that are not affecting the game state, but just living off of it, those can be moved out into their own isolated segments. And then when bugs happen, we can typically trace it back to that exact spot very quickly and easily. And then what we're doing is we are shrinking down the portions of our code that need to interact with each other, that need to understand and manipulate each other's game state. Those ones are important to track, but we don't need this level. We don't need this huge, strict series of architectures, patterns, and rules to apply to our code everywhere. All right, so in this case, I want to bring up a clear example. If you go to a game jam, you throw a lot of these standards out the window. Sometimes you keep applying them because your naming conventions, your properties, you're just kind of used to doing it, and so you keep doing it anyway. But that's still extra time. A lot of times, one thing you find when you start getting into a game jam is you just wrote a script that did the thing that you needed. It took you 5 minutes. You could go back to it and spend an hour getting it up to the standards where now you're proud to show this to other people. Or you could move on to the next component. And if you have this ruling, if you have this understanding of where you can separate that out and just say, okay, I've spent my 5 minutes on it, it's done, it does the thing it needs to do, I can move on. You could get, I was going to say 30 of those things done in an hour. You could get, I can't math right now. I can't math. 60 divided by 5. I want to call it 30. What is that, like 10? No, 5. No, 6. 12? 12. You go on and do 12 more things in that time frame? I think I need to get something to drink. All right, so what do you want to do? Do you want to get one thing done really, really nicely, or do you want to get 12 things done? Because honestly, when you start splitting out your code like this and starting to look at what you can identify and get something completed, you can get these segments done fast. That's your junior developer speaking. Let your junior developer live on. Let them be in these tiny little isolated islands where it doesn't matter about the effects from the game overall, from the rest of the code, from these bugs that want to get manipulated and hide all over the place. and get that junior developer speed back. But then for the areas that are complex, that do need this importance, pay attention. Pay strong attention. Use your standards. Do what you're going to do to make sense out of that, to make it work. It's important. All right. I'd love to hear what your thoughts are, for or against. Do you already do this? Is this something you're considering? I'd love to hear what you think about it.